Ever wondered why food gives us energy? Why plants are crucial to life? Or how energy from the sun fuels our modern world? In today's video, we'll dive into the science behind sugars, photosynthesis, fossil fuels, and renewable energy. Let's go!
Why doesn't bread taste sweet if it's made of the same stuff as gummy bears?
Sugar. It is essential for everything our body does. It is our body's go-to energy source.
We usually talk about energy in calories, which can feel a bit abstract. Like calorie is the amount of energy needed to rise the temperature of 1 liter of water by 1 Celsius. What the
Let's have a look how much energy is trapped in one tiny gummy bear. When we throw a gummy bear into melted sodium chloride, the sugar begins to oxidize. During this process, carbon dioxide and water are released, producing heat and light. It's a perfect demo of how a small amount of sugar holds serious power. One gummy bear contains 9 kilocalories. To put it into perspective, that's the same amount of energy that's in 3.5 grams of bread. But bread doesn't taste sweet, right? Why? Let's break it down.
Sugars come in two forms, simple and complex. Simple sugars heat your system fast and give you quick energy.
They also make your candy taste sweet.
But complex carbs like those in bread are long sugar chains. They take time to break down, and so bread doesn't taste sweet right away, even though it's loaded with energy.
And then there's fiber. It's like these ultra-long sugar chains, so complex that your body can't even break them down. Instead, they make your poop nice and solid.
We learned that sugars fuel our bodies, but how are sugars made in the first place? Let's unwrap photosynthesis.
It begins with the sun itself, which creates energy through nuclear fusion. Deep in the sun, hydrogen atoms fuse together to form helium, releasing a massive amount of energy.
Plants capture that energy in the form of sunlight, then use water and carbon dioxide, and boom, glucose is created. And as a bonus, they release oxygen, which, let's face it, is pretty crucial for us to stay alive.
Let's see photosynthesis in action.
We start by making a solution of baking soda in water. We pop a few leaves into the syringe and draw in some bicarbonate solution. We hold the syringe, expel the air, plug the tip with a finger, and gently pull the plunger to create a vacuum. This sucks out the air trapped in the leaves and replaces it with the solution, causing the leaves to sink. We now pour the leaves and the solution into a cup, expose it to light, and watch closely. Over time, we will see bubbles forming and the leaves starting to flow as oxygen is produced through photosynthesis.
And this indicates that sugar is being made. Let's test energy content of different fuels. We will heat up equal amount of water using the same weight of coal and gummy bear to see which rises the temperature of water the most. And we will also test fuel that our ancestors were using thousands of years ago. Poop.
Sugar is a fuel that's already partially oxidized because in addition to carbon and hydrogen, it also contains oxygen. When we burn it, it raises the water temperature by 31 degrees. Coal, on the other hand, is primarily made of carbon and hydrogen with almost no oxygen. With a higher carbon-to-oxygen ratio than sugar, coal raises the water temperature by 43 degrees, which clearly shows its higher energy content. Interestingly, our ancient fuel source is a bit like a gummy bear. It contains fiber, which is essentially sugar molecules arranged in long chains as we showed in our previous video.
So next time you fire up your grill, remember it's all energy stored from millions of years ago. Fossil fuels like coal, oil and gas contain massive amounts of energy because they've been locked away for millions of years. These ancient energy sources were formed from the remains of plants and animals, including dinosaurs.
Here's the catch. Burning then releases more than just energy. It releases tons of CO2, and that's why we are facing the climate crisis. But there's hope. The same sunlight that powers plants can now power our future, cleanly and sustainably.
Here's the science. Hydrogen is the most abundant element in the universe, but is usually found combined with other elements like in water. To use hydrogen as a fuel, we must split water into oxygen and hydrogen. In today's experiment, we'll demonstrate how solar panels can generate the electricity needed to split water and produce hydrogen. The cleanest fuel available since burning it produces only water. All we need is a suitable material like antimony selenide along with sugar and water. When we shine light on our panel, we see how hydrogen is formed.
The sun offers us a solution.
So let's harness its energy to create fuels that do not damage our planet.
In the next video,
We will take you to the other side of the mirror.
so give us subscribe.
And a like.
Thanks.
Thank you for watching.